Actually, I have an important announcement to make. So there's some candies to go around. So that's just so important things first. So just take some and please pass those around. I used to bring Swiss chocolate while I was in Switzerland, but these are not from Qatar, unfortunately. They are from... I'll just very briefly want to actually start with my journey, and there'll be a point to this in a second. So as an undergraduate, I was in Cambridge studying mathematics for 4 years. Then, as Sharuna said, I went to the Max Planck Institute for Computer Science, working on basically data structures for search engines. Then I went to beautiful Switzerland, working with Monika Hensinger on sort of auction theory, basically for sponsored search. Then I spent a summer in Microsoft research in Cambridge. I was just a summer visiting researcher. Then I went to Yahoo research in Barcelona, 3 years, also a very sunny place. And now I'm in Qatar, at the Qatar Computing Research Institute. Now, there's actually a trend to this. So if you like data, so what I plotted here is year when I joined versus latitude. So I'm moving closer and closer to the equator, sort of or so. And this explains almost half the variance in my job choice, right? So, or more actually, sort of or so, right?
The next in Singapore.
Yeah, actually, I was in Singapore earlier this year, just was checking it out. So, anyways. No, but of course, one of the points to this is in this talk you'd see a lot of correlations, right? And sort of so. And of course, you should always treat correlations with a large degree of caution, right? So I don't think, at least definitely not consciously, that it was really like that. I was trying to find a place that matched was closer to the equator. But maybe, who knows? I mean, I like good weather, but now it's a bit too good to me at the moment. Now, okay. So now, what I'll actually be talking about? So I'll be talking about social media and health. Now, most people, or when you search for social media and healthcare, most of the results that you'll find are, of this kind. I mean, there's lots of hype around, will social media revolutionize healthcare? But this type of work, is about using social media as a communication channel, sort of. So basically, they look at, can hospitals, can doctors use social media to communicate more effectively with patients? That's not the type of work that I will be talking about. So I will be talking about social media as a data source, sort of, so for personalized interventions, for something else, but not so much as a communication means. There'll be two parts to this, so I'll start with sort of giving you a flavor of this area by talking about 3 example studies. Only one of this is actually done by us. I mean, it's more like a sort of tutorial talk in that sense. This is actually work done by other people, not myself. And then the second half, and they are roughly equal, I'll talk about opportunities and challenges, because I think most of you are PhD students, if I'm not mistaken, or sort of. So there are a lot of things that could be done here in terms of sort of thesis, or at least writing a couple of papers, and I'll go more in depth. Okay, but first, sort of the bigger picture, sort of, which I think is helpful. So when you get into a health research, it's, at least to me, it's sometimes interesting to sort of, or helpful to split things along 2 dimensions. So this dimension, people are probably familiar with, right? Like acute conditions versus chronic conditions, right? And acute is basically like short-term. If today you have a running nose, if you break your arm or something, that would all be sort of short-term things, right? Things such as like diabetes or obesity, those would be sort of a long-term concerns. And obviously they require different sort of interventions, different time scales, and lifestyle intuitively has a bigger effect here than there. So there's sort of one dimension to keep in mind. The other one, which is sort of maybe not so obvious, distinguishes between sort of public health research and individual health research. So at the public health level, you look at the whole population. For example, obesity could be one example. You want to know how many people have the flu at the moment. This would be at the population level. And there, sort of the output are either health campaigns. You're trying to get people to stop smoking. You're trying to get people to be aware of sexually transmitted diseases, or related sort of policies, right? So that's sort of at the population level. Now, individual health, this is sort of when you go and see a doctor, right? So now actually there's a sort of treatment going on, right? So here the output is an actual therapy, an actual treatment, right? You undergo medical treatment. And so now let's look at sort of what has been done using social media sort of so in these things. So yeah, I will be talking about Google Flu Trends briefly, and so people have done something like Google Flu Trends using Twitter, and I'll be talking about this, right? So this is sort of like something like an acute condition, a short-term concern at the public health level, right? Or Ebola, or Middle Eastern respiratory syndrome, all these kind of things would be sort of in this quadrant. So there's some work here. There's also some work here where people have tried to look at, can we use online data, can we use social media to study obesity trends, to study diabetes, maybe even HIV, alcohol consumption and such things. So generally at the population level, quite a bit of work has already been done. Now once you go to the individual health level, things get very sparse. So here at the sort of chronic condition level, treating obesity, there's been a bit of work, but it all uses social media messages as intervention. So again, that's kind of at the sort of communication channel that I'm not really talking about today, but a tiny bit of work has been done there, not so much even. And here there's at least nothing that I'm aware of, right? Sort of how could social media really help to treat an acute condition for the individual, right? Maybe it doesn't even make sense, but this is sort of something to think about. So most of the work I'm talking about today is sort of up here at the sort of level of public health. But there are some efforts to push this down and actually look at the individual health. Now, why would you actually bother with social media, right? So what could it sort of almost? Well, the obvious thing is, okay, there's lots of it, right? It's big. You could do studies across countries. It's very easy to get data for different countries. If you have a script that gets data for Sweden, just with a bit of tweaking, you can probably get data for Germany or even Qatar. Of course, it's cheap to collect, right? That sort of goes hand in hand. Things such as keyword or geographic-based collection are really, really standard. I mean, I'm sure many of you have done these kind of things before. This is also now an important thing. So there's a bit of sort of longitudinal data for a given user. You can go back in time to a limited degree. So in the example of Twitter, you can get the last 3,200 tweets and actually see, okay, somebody who's sick today who tweets, oh, I have a running nose, oh, I have an upset stomach. What were they tweeting about yesterday, a year ago, or sort of, or maybe even a year ago, sort of. So this is very interesting. This is something that usually is harder to get, that you can't just get from a single query, for example. This is also another thing which is very valuable is social network data. So like when it comes to social studies, usually it's hard to get network data, right? So this is like a whole research field basically sort of came up because now through online social media, we actually have access to this type of data. And then last not least, so there's also lifestyle data, right? I don't only tweet about today I'm healthy, I tweet, or I'm sick or sort of, so most of it is just, oh, now I'm in Sweden, now I went for a run or something like this, right? And so this is of course now relevant if you want to study lifestyle diseases, such as obesity in particular. You can actually learn something about how people live, right? So those might be reasons why you might actually bother with social media. Later, I will of course also tell you about why not bother with social media, right? So of course there are, advantages and there are drawbacks, and I'm not saying, social media is the answer for everything. Now, with that in mind, let me take you to these three sort of example studies that I think are good at sort of giving an overview of this type of work. So this is work done by David Boniatowski, Michael Paul, and Mark Dresden. It was published about 2 years ago, and it looks at flu tracking. How many of you have heard of Google Flu Trends before? I guess most, or probably maybe. So Google Flu Trends, if you just search for it later or sort of or so, it's a service that looks at web search data to track flu activity. So here currently, according to what people search for at the moment, the activity in Sweden is quite low, right? And the type of queries that were actually found through data mining, that best correlate, often make sense, like headache, running nose, red eyes, literally flu symptoms or sort of so, right? And so if many people search for flu symptoms, then, intuitively, many people are actually affected by the flu. Why does that matter? I mean, why do we care how many people are affected with the flu? Well, the thing is that doctors, or at least the sort of health official at the highest level, only know this about 2 weeks later. So when there's a flu outbreak, only the sort of the officials sort of only have data that's 2 weeks old, basically, because it takes a lot of time, surprisingly, to aggregate this at the various levels to have a picture about the whole nation, right? Whereas with this data is updated daily, so you have almost real-time information about what's going on about the flu. And of course, that's important when it comes to being prepared. Should we produce more vaccine, right? Should we have some intervention or sort of? So this is important to know these things early on, especially like if you imagine something like Ebola or something really spreading or so.
Ingmar, there are so many curves here.
So this is they come from past years. So this is sort of each of this curve is a sort of historic trend. So you can sort of select here, and then you'll see. I don't remember which year is which sort of.
Okay, but the one that is dark blue.
This is up to now we are sort of here, right? Sort of so like the sort of so, and then it sort of continues. Yeah, do interrupt by all means. Thanks for the interruption. So definitely, if something doesn't make sense or so, I'd be happy to try to explain. So given this question is can we but then I don't know how many were following this. Actually, Google Flu also used to work great, but then in the 2012-2013 flu season, so over sort of the sort of Christmas 2012, basically, Google Flu got it horribly wrong. I mean, it was like a factor 2, basically. It was way overestimated. At that point, overestimated. Like initially, they underestimated. At that point, they overestimated, right? And one of the reasons that they overestimated is that flu was covered so well in mass media that it sort of changed the search behavior. Now people were searching out of for sort of flu-related things just maybe out of panic or something. So not because they were actually affected, right? Because it was all over the media, right? And if you only have the query like running nose, it's kind of hard to tell, well, does this patient really have a running nose, or he read an article that if you have a running nose, you'll all die of flu or something or so, right? And so this then led to sort of people actually questioning, well, is Google Flu really the answer to this problem? And there were related sort of things, and people also found other criticisms of Google Flu Trends, like related to how transparent the whole setup is, for example. So the question that people then are asking is, can Twitter do better, or another social media source? Although mostly it's used Twitter because the data is so easily accessible, right? So can you give a more transparent prediction, because now you really know how you collect the data, exactly what is done, and also could you potentially give a more robust prediction, because now you have some context. I mean, you have not just the one word, you have at least a tweet, which might look short, but is at least longer than a search query, and maybe even things before and after, right? So that's sort of the general question in this area. So a lot of people...
How do you know Google didn't use this data? Maybe Google already uses it.
Uses... You mean Google could use which data? Well, they claim that you just use a search data, right? I mean, there's a paper published that describes how they do it, and there they just say they look at search volume, right? There's a related service, by the way, this is less well known, but it's really good, Google Correlate, where you upload a time series and Google Correlate tells you which queries correlate with this time series, right? And so both at the temporal level, but even at the regional level. So if you have either a geographical pattern that you want to try to find if they are matching keywords, or a temporal pattern, search for Google Correlate. And sort of Google Correlate kind of underlines Google Flu Trends. They even say it's exactly how we built it. We just uploaded historic flu trend data and we find the queries that correlate best with it, right? Of course, definitely Google could do more, right? I mean, Google has, of course, also some context about you, right? Like if you're a registered Google user, they could analyze your email and your social network or sort of so. At the moment, they don't seem to be doing it, but they could. I'm not saying that they can't, right? Sort of so. But then, of course, there's still this transparency issue, right? Sort of so. With Google Trends, you don't know what they're actually doing, right? I mean, to a certain degree, you don't know. So anyway, so when it comes to using Twitter for this, many people have tried it. There are at least 40 papers, and this is just a link to Google Scholar. You can use it later in the slides. And typically it's a sort of very straightforward setup. So you collect Twitter for a set of keywords, like you have like fever, headache, running nose, sore eyes, or sort of so. And you get all the tweets matching, one of those keywords. Usually there's some post-filtering done, right? So for example, maybe Saturday night fever is not really the fever you're interested in, right? So you kind of have to remove some false positives, sort of or so, right? Like I don't know what maybe some maybe running eye could be used in some other context as well. And then basically you just do sort of some temporal correlation. How is the filtered volume correlating with the sort of with the historic data of historic flu activity? So this sort of about 40 papers that do this. Generally, they have these two major weaknesses. So generally, they only look at a single flu season. So they just have data for one flu season. So and it's not. So there's always a peak in the fall, right? Like October, November in the northern hemisphere. So even without Twitter, I can tell you, in November there are going to be more flu cases than in July, right? Like, okay, so they only use that a single flu season, which also makes training and testing hard, right? If you train on January to October, and now you want to test on November, November, December, that's hard. And of course, these papers are usually done in retrospect, right? You say, oh, in retrospect, I could have predicted flu activity. Well, now we're no longer interested, right? I mean, you can always find some model that predicts past historic data. But now, actually, it seems to be that actually now people have overcome these weaknesses, sort of. So this actually got quite a bit of attention. So here's a Washington Post article where it now says, a better flu tracker using Twitter, not Google, right? And interestingly enough, they actually did this for the season where Google got it wrong, and they built the system in advance, and they had it up and live and running the whole time through. So they didn't tweak it. I mean, I don't know. At least they don't claim they tweak it, but they made the prediction every single day, right? So this is sort of during the season that Google got it wrong. So that's quite promising, sort of. So let me tell you a bit about how they did it. So at the very, very high level, it's the same sort of thing. They start with some tweets, and at the end, they get some sort of estimate, right? But now what's actually happening in between? Again, this is sort of fairly standard. So maybe actually it's not, because it's sort of a multi-step, as you see. So first, they filter out queries that are talking about a health topic. So they build a classifier. In this case, they just use tokens as features. So they just very, very simple, like sort of, undergraduate level, basically, build a support vector machine classifier and said, is this tweet about health or not? Anything about health. Could be about, I don't know, obesity or anything, really. Then in the next step, they have two more filters that both use the same sort of setup. So the next filter, is it about influenza, which is a fancy word for flu? And then, is it actually about the user being infected or not? So am I talking, oh, I have the flu, not I've read an article about the flu or something, sort of, so I have the flu. And others have tried this before, but I think the reason that they get the performance they do is they put a lot of effort in feature engineering. I mean, here for this part, really, is it about me having the flu with all its linguistic nuances or sort of so? They looked at a lot of things. I mean, they looked at the word classes, which things are nouns or verbs or adjectives. They encoded retweets, mentions, emoticons differently. They did part of speech tagging. They looked at verb phrases. They looked for pairs of words that contain a pronoun. They have verb-noun pairs, and they threw a lot of sort of linguistic stuff at this. So a lot of feature engineering, or sort of, so to get these steps right. This step is reasonably easy, just something about health, okay, that you can do. But is it me being sick with a flu? That took a lot of work. To get right, and then as an actual, yeah, exactly. They use yes with an L2 regularizer. Yeah. Another thing they did that's usually not done is they actually then also looked. They tried to geocode the tweets. So they had a system. This is, by the way, this is open source. So if you need a geocoder for tweets. Maybe search for Carmen, or otherwise I can give you a reference to sort of to find out where is this tweet actually from. This is a system they built for geolocating tweets. Right, sort of. So using whatever information there is, it could be if it's geocoded already with GPS. Okay, that's easy. But maybe it mentions the location, or a user mentions something in their profile. So they built a system for this. So far, this is still fairly standard. Now, one thing they did, which is also quite nice, is they then built a reference corpus. So they just used a general set of tweets, just 1% of all tweets, and but didn't filter for health, didn't filter for influenza, didn't filter for anything else. Just looked at, okay, this is just a reference. So they know, okay, overall, during a given time period, there are so many tweets from New York City. And then they could sort of compare, well, how many of those passed the filter, right? So now they have sort of like a reference of all Twitter volume, because maybe the obvious thing is Twitter population continues to grow, right? If you don't normalize, you think, oh, there are more and more, if you just count, you just see, oh, there are more and more tweets about flu all the time, right? Oh, there's an epidemic. No, well, it's just user growth, right? It's not an epidemic. So you have to do some sort of normalization, right? And this is a nice normalization. You have just a baseline to normalize against. And so then they did this, and with this they actually got pretty good levels, sort of, or so. Like so at the US level. So this is now temporal correlations. So temporal correlations of 0.93 at the US level. They also zoomed in to New York City, and there again at the temporal level for New York City, similar, very very high levels of correlation. So this is definitely at a level where people show interest, right? Where actually now health officials could start using this sort of thing.
Means exactly?
So this is just it's just R correlation. So you have one time series of historic flu activity. So reported like 2 weeks later. So 2 weeks, and then here's my prediction. Here's what the ground truth is, and you just look at sort of the correlation. How correlated are they? Typically, people in this use correlation, but of course you could try to look at some other error estimate. How far off are you? But here people usually use this sort of linear correlation. So this is just sort of one type of work to show you what people have looked at. Now on to the next example. So it's work done by Adam Sadilek and Henry Kautz, also about 2 years ago. So what they looked at geo-tagged sick tweets from New York City, right? So here each dot is a tweet. A red dot is a sick user. A yellow dot is a non-sick normal user. These purple are areas of pollution, right? And so here now somebody is sick, and they were interested. Can we kind of explain why somebody gets sick? Maybe if somebody is close to pollution, they get sick more often. Maybe if somebody hangs out in certain areas, they get more sick. Or if they live in a poor neighborhood, they get more sick. If they have less friends on Twitter, they get more sick. These sort of things. That's what I was sort of trying to explain, right? Well, you're laughing. Well, why don't you see the actual results? So it's then you stop laughing. Then you try to get more followers, I guess. So their question is sort of, what determines how healthy or sick a person is? These are socioeconomic status, this is social status, some mobility patterns. So they get data for 1 month in 2010. They queried the Twitter API periodically to get tweets for 100 kilometers around New York City. Could have, if you're just some detail here, they could have used the streaming API, but usually the REST API gets you more results than the streaming API. So if that's something you're interested in, I can tell you more about this in detail. It's something that it shouldn't happen, but actually it does. So in total, they got 60 million tweets from 630,000 unique users. So for like a health study, this is big data. Of course, it's not big data, sort of for Google or Yahoo. But now they only looked at users that had enough temporal, sort of longitudinal data. So now they only used users who, during a 1 month period, tweeted at least 100 times, right? So and geo-tagged, right? So 1 month period, 100 geo-tagged tweets. So now still in New York City during that time, now it would be higher. They got 6,000 users. So now this is the 6,000 users they analyzed in their data set, right? So very odd sort of user set, right? That's of course to be kept in mind. So first thing is, of course, they try to, well, what are the tweets that mention about user being sick? So again, very, very simple. They cast everything to lowercase. Basic cleaning, some punctuation is removed. Stop words, I believe, no, I'm not sure about stop words. Stop words might or might not have been removed, but still sort of fairly basic stand-up. They used uni, bigrams, and trigrams as token, right? So sort of a cast 2 lower would be uni, bigram, and trigram. They used mechanical Turk to label a bunch of tweets as either sick or other. And then again, they train SVM, so SVM seems to be popular for these sort of things. And now they reported amazing results. I mean, if you see this, wow, really, is this true or sort of or so? Like this is like amazingly good sort of or so. So they claimed, 0.98 precision, 0.97 recall. They didn't mention the class distribution. I don't know why. Usually you report those. It's a bit odd. Then so now they have this amazing model, and now they run all the tweets through this amazing SVM prediction. Is this tweet about person being sick, or is it not about a person being sick? The prediction they compare, so the SVM output they convert to probability. They don't mention how. Again, if you've used SVM before, there are ways. There's like this plot scaling or sort of so, but they don't mention exactly what they did. Okay, they somehow converted SVM output to a probability. And then, so now they had a probability of a user's message of being classified as being sick. And this is now the key score. So if a user has M messages, they just sum across all the user's messages, the probability obtained from the classifier that this tweet referred to the user being sick. And then they just average this. Right? So now for every user, they have one such value, which is sort of the average sickness of your tweets, if you would like, sort of. Right? So that's now the value. So now they have one health value for user, or here it's a sickness value. So this is high means you're very sick. Here just to show a bit about the model. So this is features that are indicative of users being sick. Here are features that are indicative of users not being sick, right? And some things are interesting, right? Sort of so sick off is, you have to remove, right? And this is actually something that was other people have observed as well. If you just have fever, Bieber fever is a huge thing, right? You have to remove Bieber fever, otherwise, the whole subpopulation is sick. Maybe they are sick, but they're not sick for the reasons, that you would probably want to catch in these sort of studies, right? So. What would it's a mental condition. It's a mental condition, yeah, exactly. Exactly. So this is another condition, right? So now, okay, so now they have this health value for every user, and now they looked, okay, what are the variables that explain how healthy a user will be? So one is physical encounters with other sick people, right? So this is interesting. I mean, if you think it was a very sparse set, it's 6,000 users. How many of those are going to meet each other, sort of, so in reality, right? So it's not really physical encounters, more like going to the same sort of places, right? So here they defined this. So if you met a sick person in the same data set, so you had to be within 100 meters. They tried different time ranges of a tweet that was classified as sick. So now it's an individual tweet where the majority of the probability was, yes, this tweet is about being sick. Another variable they looked at is how many of your friends are sick, right? Maybe you get more sick if you have friends that are sick, right? They looked at Google Places, and they looked at, well, what kind of places do you go to, right? So they had like bars, nightclubs, transit stations, or bus stations, etc., parks, gyms. So if you were tweeting within 100 meters of one of these venues, they kind of assign you as if you had checked into that venue, right? So if you tweet from close to a bar, you've checked into the bar, sort of. So very, very simple. They didn't look at opening hours. They didn't look at anything else. It's just very, very simple. Pollution, I mentioned, sort of, so this geographic pattern. Socioeconomic indicators, so they use zip code to derive is this a poor or rich neighborhood. And then all of this, they try to predict this individual sickness score that you saw before for a given user. So here's what they found. So this is correlation. So this is now correlation with health. This is the negative of the sickness value. So things that are sort of on the right make you healthy. Things on the left make you sick, right? So some things are maybe obvious or not. So if you're far from pollution, that's good. That's really, really important. That keeps you healthy. If you visit near pollution, that's not so good. That makes you sick, right? This is kind of obvious, right? Other things are counterintuitive, so you should also stay away from gyms. So the bigger the distance from gyms, and the more you visit gyms, or sort of so, right? And again, it could just be an artifact. Maybe gyms are in a cheap part of town, so if you go there or something, or sort of so, I don't know. I mean, I'm not sure. So this already shows the limitations of this correlation type analysis. But anyway, so that's what they found, right? So people.
It's positive. You are healthy if your mean distance from.
Yeah. So a high distance from gyms it increases your negative sickness score. So.
Countryside city, though, is it? Because you have it for stations and bars.
All of this is New York City. All of this is within New York City. All of these use are within New York City.
Yeah, but it might be proximity to countryside. You know, you're further away from the gym, the bars, the station, so you're probably in a cleaner area.
Yeah, maybe.
They're all quite similar.
I mean, some funny things like if you visit gyms, then
You get sick. Yeah, exactly. If you even if you mention gym, this is actually interesting. Even if you mention gym, right, you get sick. So yeah, there you go, right? So the findings of big data, right? Yeah. Other things actually are in line with previous findings. So there's lots of work that shows if you have a higher social status, you'd be healthier. So they also looked at graph measures, sort of, how central are you in the Twitter graph and such things. And the more central you are, the healthier you are, right? So that makes sense. And if you have sick friends, that's bad. If you come close to sick people, that's bad. There's some demographic influence as well. Now just put together, sort of to summarize this sort of right? So with all of these, sort of put together in a single model, you can explain about actually more than half the variance in this value of kind of the, how your sickness, your sickness score, how many of your tweets are about sickness, right? Again, all of these are correlation studies, right? There could be many other correlates. For pollution, it might make sense that maybe there's a causal effect, but again, it could just be pollution is in cheaper areas or something, or, and if you're close to those areas, that is really the problem. Still in it, yeah, please.
Just as a comment, it might also make sense to correlate having pets.
Oh, that's interesting, yeah.
Because there are studies showing that if you have a dog, you're less prone to getting
Yes.
heart attacks because you have some.
Yeah. So that is a nice type of study, right? Especially if you have an existing hypothesis that you like to test or sort of so that definitely. So they didn't look at it, but this is the sort of thing that people would be interested in, right? Or I think there have been studies trying to show whether dogs or cats make you happier. I know some people at Microsoft actually looked at this. But anyways, the last example before I talk about some sort of opportunities and challenges is work that we've done in the space. So this is joint work with Sofian Abar and Jelena Mijova, both of whom are also at QCRI. So. Now this is a bit old, but in 2009, a study claimed, Twitter is mostly pointless babble, right? Or not mostly, they said 40% of Twitter is just pointless babble. And they defined pointless babble even as these are the I am eating a sandwich now tweets, right? And for most kind of studies, I think, why do you need to tell me this, right? I mean, what's the point of this? It was like, just don't, right? But of course, if you think about it, this person just told you what they had for lunch or dinner or sort of. So now if you want to study food consumption, if you want to study obesity, this is a great data point, right? In fact, I did this yesterday. There are a lot of these data points, right? So all of these people just tweeted what they were having for, or here somebody's having a barbecue sandwich, somebody is having a bagel sandwich, somebody is having a breakfast sandwich in the evening. It's pointless babble, probably, but it's still data if you want to study food consumption, right? So kind of what we were interested in, what can we actually explore these things? Can we explore food? So can we use food studies to study obesity patterns, right? So can we actually use this as data? So how did we collect the data? So we started with the streaming API, so the Twitter, again, I guess it's again a Twitter study, using Twitter Streamer to look for things, any tweet mentioning eat, cook, lunch, dinner, breakfast, about a dozen terms, roughly, like sort of so related to food consumption. We did this for 1 month, got about 50 million tweets. Then again, we only looked at the geo-tagged tweets of these, and there were about 400,000 users that had at least one geo-tagged tweet. And the reason we did this is that then we could use the latitude longitude to actually get census data. So through the census data, we know if somebody tweeted from a high income area, or in particular, if somebody tweeted from an area with high obesity rates. So this was important for us. From this 400,000 users, we only had time to get data for just over 200,000 users. So for these 200,000 users, we have their public tweets, their profile, and their friends and their followers. So in total, it's just about 500 million tweets. network is reasonably sized with 2 million nodes. Now, this is at the user level. So to find out what is food, we labeled things that co-occurred often in these eat, cook, and lunch food sort of. So I mean, if you think about, if something often co-occurs with eat, it's going to be a food item, right? So we labeled the top 1,000 co-occurring uni and bigrams. About 460 of those exactly 460 turned out to be food. And then we mapped these to caloric values. So there are, let me just maybe click this link. So there are websites that would tell you, just how many calories something has, right? So here it's about, let me see if I can, how do I scroll down? Oh yeah, okay. Here it's a fruit salad containing peach, pear, and apricot, contains per serving size, all of this is per serving size, contains 125 calories. So this is a sort of, now how do I go back? Now in our data, we got a slightly lower value because we averaged across different types of fruit salads. So some fruit salads have more calories per serving size, some have less, right? So if you mention pizza, per serving size, 478 calories, fruit salad, per serving size, 99 calories. And then we would just average. So if you mention a food, what is the average caloric value of a food you mention? Right? Is it high in calories and low in calories? Right? That very, very simple sort of thing. Now we have it at the user level. We then aggregate it first at the state level. So here I'll show you results for the state level. So on the y-axis, you have actually obesity rates for the different US states. Right? So this is sort of the southern states, so Alabama, Mississippi, Louisiana, South Carolina, sort of. So they have high obesity rates in the states. Right? On the x-axis, you have the average calories they tweet when they mention food. Right, sort of so. And you see generally states that have high obesity rates are also states where users, on average mention higher calories. That's already cute, right? So you can get this sort of a nice graph. You can look at the actual correlation values if you like. So both sort of value, linear correlation, and sort of rank correlation. So this is using all of the tweets that I mentioned. And then we looked at obesity and diabetes. Of course, they are strongly correlated. So typically what you get for obesity also holds for diabetes. And we broke it down by food and beverage, so just to see if there's a difference. And I mean, all of those are highly significant, or it looks reasonably promising. So this is there seems to be some signal, at least at the state level, what food is being mentioned, and is it dense in calories and obesity states of that level. Now we try to drill down. So at the state level, we have many, many, many users. At the county level, we're talking about sparsity issues. Still, so this is how we tried next. So now we try to predict county level obesity rates. And here we actually so far we haven't fit any model, right? This was just correlation. There was no model fitting at all. It was just averaging and showing correlation already. So now we actually try to fit a model. So now we use this average calories that it was at the county level. We use the actual food names as features, so the actual food names being mentioned. We used from previous work, there's this language inquiry word count, I believe. It's sort of like it maps words to certain word classes. This was just to have something comparable to prior work. And demographic features. So this is kind of the baseline. So even if you don't tell me anything about social media, if you just tell me what sort of people live somewhere, I can tell you, if they are, they're all poor, it's a black neighborhood, obesity is going to be high, right? I don't need social media for this. Okay, and this is kind of like a baseline you have to beat. Otherwise, it's almost pointless to use social media. Okay, we used rich regression, used cross-validation. So here's now what you find. So this is now, so again, this is correlation. So high is good. So it's linear correlation. So high value is good. The gray is demographic features only. This is kind of the baseline you sort of have to beat. If you don't beat this, it's not super interesting. This is prior work. So this is this bar. This is from previous work. And now, so this is the feature set that I showed previously. So this is now using only calories. So now, even though at the state level it performed quite nicely, at the county level it didn't perform as nicely, and we believe the reason is sparsity. So now for a single county, we might only have like 100 users or something or so. So there it's really hard to summarize, whereas at the state level we have several thousand users, so we can actually say something about the food consumption. So the main point here is that the actually using the food that is being mentioned, not mapped to calories, just the actual food, the string pizza as a token, together with demographics, you actually get a pretty good value, sort of explaining the obesity spread in the US.
So with adding the calories, you actually...
I think a good question. I think did we try? We probably tried this when we didn't include it because it didn't work out. It's a good question. We definitely tried all pairwise combinations. Yeah, I'm pretty sure. I'll have to look it up. I guess already. Yeah. So now this model is now trained at the county level. Now for the next step, you have to sort of bear with me. Now we use this prediction at the individual level. So we label each user with the probability of being obese based on this model that is used on the county level, right? We don't have ground truth at the individual level, so we don't actually know if a user is obese. That's one of the problems I'll come back to later, but we use kind of our model now as ground truth, right? So take that with a huge kind of, so we label you, according to this model, you are 80% obese. Now, doing that, we can do some fun stuff. So now we can look at the social network, because now we have individual obesity labels, again, derived in the way that I said, that's not perfect. So now we call a user active if he's in the top 10 in terms of probability of being obese. Among all our users, you're among the top 10 that are most likely to be obese according to our model. Now we look at what happens if you have friends that are also active. Right, so here it's the following network where we looked at mutual following. I follow you, you follow me. Okay, so the baseline is sort of 10%. So just 10% of all users are labeled active. Okay, if 0 of your friends are active, you're below that baseline, right? You're maybe at 7-8% sort of. So, right? If even one of your friends is in the top 10%, the probability that you are also in the top 10% goes up, to, I don't know, 17%. If you have 2 or 3 or 4 or more of these friends, sort of it continues sort of, and then it saturates. I don't think it's going down. I think it's just too noisy, sort of, so, right? And this holds both for the following network and for the mentioning network. So here it's mutual mention. I mention you at least once in a tweet. You mention me at least once in a tweet, right? And again, this is just correlation, but we can't later get back to these claims about network influence, but it sort of shows you that you can do some interesting stuff using, as you know, the social network. So, so there are lots of other studies, right? Just if you're interested in this kind of stuff, just some pointers. People have looked at using social media to find adverse drug reactions, right? Like both from dedicated forums and even just general tweets. Somebody tweets, oh, I took so-and-so and now I have a headache or something. Mental health, people have looked at tracking, depression, through tweets. People have studied dedicated social media, so there are forums just for weight loss, just for obesity, just for cancer. So this is not general social media, it's still social media, and of course there's a signal there. And of course, as I mentioned, there's a lot of research on using social media for actual health communication. Now, the last part of my talk, okay, I have to go a bit faster. I'll actually want to talk about some of the opportunities and challenges, sort of, if you want to work on this. One of the things that I'm really interested in is actually now using content-based image analysis, right? So here, if you search for food porn on Instagram, there's a bunch of sort of things. And so this tells you what people ate, right? And of course, now if you want to understand what people ate, you can look at the hashtags, or you can try to find actually now some deep learning-based approach to actually label these images automatically. And there are already tools out there. This is a company called MetaMind. If you search for it, it's a public tool, right? Where if you upload this image, it would detect this is 95% probability of hamburger, right? Even if it doesn't have any tag, no tag whatsoever, just based on the image, it detects this is a hamburger, right? So this is, of course, now opens up new possibilities, right? Of course, this tool doesn't work great yet. So this is a standard Swedish dish, if I'm not mistaken. So this is pea soup and pancakes, I believe. And the same tool thinks it's crème brûlée or something, or so, which is way off, right? Of course, and like so. I mean, these tools, they are coming, but they're still in its infancy. Still, there is definitely some promise there. And in the next couple of years, you'll see more and more studies that actually use the image content for such studies. Another example is, here are people tweeting about pizza, but they all have profile images, right? You could look at the actual profile image. Who are these people that tweet about pizza? One thing you could do is you could try to infer demographics. So there, again, this is an existing tool, Face++. that would mention the age. So here I am, I don't know if you can, 37 plus minus 7, which is pretty spot on. I think it's 2 years off, right, at this year, sort of. And it gives an error rate. It thinks I'm 99.9% male, which I feel, you know, very full of testosterone, sort of, or so. And later it always says I'm white. So again, you could try to use such tools, right? And this is something you could now try to infer. Face plus plus. So this is a public tool you can use, right? It's fun. This doesn't have a tool yet, but it's also promising. So there are people that are trying to infer the body mass index just from a face. You know, is this person obese or not? Right? If you have this, then now you have ground truth label at the individual level. I just look at the pictures you're sharing and say, oh, you're a bit chubby, right? Sort of. So now I can actually. And now I can actually do this what I did before with sort of dirty labels, you know, at a much better level. Yeah, this is something also interesting. So this is another tool, Imager. So here are people that have some bottle of wine, and the tool adds the tag drunkard. I don't know, right? If you see this sort of, so it's a kind of implicitly, do these people look drunk or not? You know, classifier sort of, so right. But you know, this is funny. But actually, we just recently we submitted a paper that actually shows these tags are help to model excessive drinking, because people wouldn't tag this image themselves as, you know, me getting wasted or alcohol or something or so, right? They would just upload it and maybe tag it as party, if anything, right? And so if you have something that can pick up alcohol being consumed, you can actually do some fun stuff, right? So when it comes to like drug abuse, there's huge potential. One study I just want to mention, so you could even look at eye colors if you want to study like things such as sexual fidelity. You could look at, do family pictures often show incoherent eye colors, right? And you could try to estimate certain rates of unnatural inheritance if you wanted to, right? But that would be very controversial. That's why I stayed away from this sort of, so, right? But just as a sort of, you know, there's lots of information hiding in images. Yeah, there's another opportunity, of course, network influence, or it's also a challenge, sort of. So, how many of you know this Christakis and Fowler study on the spread of obesity? Sort of that. Well, maybe.
Your friends can be.
Yeah, make you obese, right? What they really said is that it's not just obese people hanging out together. Is, you know, that if you had a friend, you know, they sort of increase your probability of eventually becoming obese, even if you're not obese, right? Sort of. So the. If you have an obese friend, so if you have oh yeah, they looked at friends, they looked at siblings, they looked at spouses, you know, all of this. Even if you're not obese, if you marry somebody that is obese, you know, you have an increase of probability of becoming obese, right? And they claimed this is social influence. It's not just homophily, sort of, so. And there was cited a lot of times, like, you know, almost 3,000 times. But then it was also criticized, so it was picked up in, you know, popular media. But then others have criticized it. They said, look, there are certain statistical phenomena. You didn't look at the people that are not friends. People remove friendships, or sort of so. That says you can actually explain a lot of what you observe through other models. So this has been questioned by various people. Again, somebody says, you know, there are many things that are confounded in this study, so you can't really claim causality. So people have criticized this, and it's still a bit up in the air at the moment. There's some sort of one paper, oh, you're all stupid, and there's another paper, no, you're stupid, sort of going back and forth on these sort of issues. So now the sort of, you know, people say, actually, maybe it's not so easy. Maybe your friends don't make you fat, right? Sort of, now if you wanted to, yeah, so here what the New York Times says, you know, at the heart is this old conundrum, how certain can anyone be about conclusions based on observations of how people behave, right? There's no intervention. You just observe people, and now you make causal claims, right? So this is very hard, right? It's very, very hard. I'll get back to this in a second, right? So here, there's no randomized controlled trial, right? So you just have observational data, right? That's all you have, right? So then it's really hard to tease apart, you know, homophily. It's just, you know, friends are similar to you, right? But I don't influence. I sort of choose my friends because they're similar. There's environmental facts, right? So as an example here, so if I go running, maybe the next day my friend goes running. Did I cause my friend to go running? Well, in Qatar, Friday is a weekend, so I go running on a Friday. My other friend goes running on a Saturday because Saturday is a weekend, right? It's just sort of, there's an external factor that analyzes everything. There's the day being a weekend, right? So it's not that my friend goes running because he saw me posting, oh, I ran so much, right? And then, of course, there is still the possibility, yeah, there is some social influence. So where's the opportunity in this? There's all the challenges so far. Well, people are now thinking about natural experiments, right? So recently, Sina and Aral mentioned this idea of using weather, for example. Weather is more or less random, right? It's kind of like a randomized controlled trial to a certain degree. Some days, it's raining, some days not. It's not perfect. I mean, you can discuss more about this also. And what they are interested in is, if I live in a city where today it's raining, so I can't run, do my friends also stop running because they don't see my updates about me going running, sort of, or so, right? So this is now getting sort of close, right? So this is interesting. So what are natural experiments that would take us much closer to sort of causality than just the observational part, right? Other natural experiments, or maybe there's a local campaign, right? Maybe here, just only in part of Stockholm, there's a healthy food campaign, right? Does it actually spread through the network to others, right? Sort of. So if it's just one part and it was sort of randomly chosen, ideally, it's just sort of hard. Anyway, so here there are some opportunities. If you have good ideas for natural experiments and you derive something related to causality, that's very interesting. That's really, really interesting. People would love that. Another option, so I've talked only about social media, but another hype is, of course, quantified self, right? And the two meet. So here people, there are smart scales, internet-enabled scales, WeThings make some of these, that automatically tweet your weight, if you let that, right? You step on the scale, and your weight is being tweeted, right? So here it's in stones and pounds, so it's not metric, right? Now, for such users, you have very accurate, automatically generated weight series, which is great. But of course, you also have other things, right? You have their general sort of stuff. Who are their friends? Who are they following? What sort of stuff do they do, right? So now, if you combine these two, again, that comes with new things that you couldn't do before. Now you have very accurate, not self-reported. I mean, sort of self-reported, but not really. Sort of, it's kind of opt-in automatic self-reporting. It's not just weight. There are people that automatically tweet about their sleep. Here somebody slept for like 10 hours or something or so, almost, right? And he's tweeting that. And sleep is also important because sleep has been linked to like insulin, for example, if you're diabetic, has been linked to happiness, academic performance. All of that relates to sleep, right? So now again, for this user, you know how much the user sleeps, and you can link it to other lifestyle things. Another thing here is sort of food diaries, right? So here somebody mentioned their food diary. If you go to this link, again, here you see what she logged. This is now manually logged at the moment, but you see, all the food you logged. And again, now you could actually correlate this with her social network and sort of see if there's some. So she had a Jack in the Box, whatever, something bacon, if she was above her calorie goals. So there's definitely some, promise there. Another opportunity is now, all of this is so far at the public health level, right? So now can we actually do something for the individual health level? Suppose you go to a doctor looks at a screen and has some sort of summary about you based on your social media, right? What should the doctor see, right? Okay, here's an example, right? So here's Mark Zuckerberg's sort of Facebook page, maybe a bit old. This is probably too much, right? Should a medical doctor who's treating Mark Zuckerberg read all of this stuff? Probably not, right? It's a waste of time. Like doctors don't have time. They don't want to read, whatever, right? But if you could extract something that is a bit more relevant, like as an example, right? If you say, oh, Mark only posted unhealthy food pictures. Look at this. There's burgers and milkshakes, and it didn't refer at all to physical exercise. Maybe his mood's dropped, and maybe it could be related to an increase of the usage of #work. Okay, that could be interesting. All his interests are sedentary, just online social networks, TV series, advertising, no active interest, right? And maybe even his sort of social network, right? Maybe this person is a runner, that's good. This person holds a wine glass in the hand, that might be bad influence, right? Maybe you want to tell this person to stay away from this guy, right? Like sort of or so, right? I mean, this is of course all made up, right? But sort of like, what should you show a doctor, right? What information could doctor potentially, use in treating you for something, right? Is there anything out there that actually doctors would like to know? So that's another huge opportunity. Some of the challenges, sort of just very briefly. Of course, there's a huge ethical challenge, right? I mean, generally social media comes to audio, but now we're talking about medical data, right? Medical, even if it's out in public, that's really a problem. How many of you have heard about the Samaritans radar, by any chance? This was an interesting idea. This was an app where you could sort of, it would tell you if one of your Twitter friends tweeted something about depression. Oh, I'm feeling low today, or I need help, or something, or so. Right? That would be a great idea. You know, if some of my friends is in trouble, the app lets me know, hey, so and so, Sharunas needs help. Sharunas just tweeted, oh, I'm feeling low. There's all these boring talks. Somebody help me, or something, right? Like so you know, it sounds like a great idea, but it was a huge backlash, and they had to withdraw it because they were worried that people would use it for mobbing, right? So now I can just follow all the people I want to mob, and I get, when they're down, now Sharon is at his weak, and now I can really rub it sort of in, right? So now I know he's weak, right? So in the end, they pulled this app, right? So it's still, so definitely there are huge concerns that you have to do these things right. There'll be an outcry. Yeah, there's some attitudinal promise, right? Like if you want to get medical doctors to talk to you, it's not easy, right? I mean, you can't enter with like, oh, social media cures cancer. And okay, well, what does the social media bring to any of this, right? It's just leave me alone. I'm trying to cure cancer, right? Like, so there's some, you have to sort of, this is a lot of sort of social engineering. I don't know how you want to call it. That's required. Of course, data quality, right? Obviously, there's selection bias. Who's on social media on the first place? Who's using quantified self stuff? Who would tweet their weight, for God's sake, right? Like right? So clearly, this is not representative, like medical trial and so. Of course, there's reporting bias. Even if I'm, maybe I tweet about my food, but I might not tweet about sexually transmitted diseases, right? Like so. So in certain domains it might not be so. Although you're laughing, people have found that areas with more references on social media to alcohol and dating sites are also areas with more sexually transmitted disease, right? So they're indirect clues maybe. Lack of individual level ground truth I mentioned, right? Like who is obese, for example. So far that's not. You don't have a label, but again, maybe image-based could be a solution to get individual-based label. Who's smoking? Again, maybe image-based could be. Who has the flu? Yeah, maybe. This is another huge challenge. And then the last one is, of course, the biggest one. Actually having interventions, right? Not just studying, but now actually trying to change something, right? So like on the. Ideally you'd like to have some randomized trial or, A/B testing if you like. So for your doctor, I show something, the other doctor, I don't show anything, and then trying to show that it makes a difference. I'm about to finish just one slide of advertising. So if you're interested in sort of using Twitter for sociological studies, we recently published a book called Twitter, a Digital Socioscope. So if that's sort of an area you're interested in, check out our recent book on the topic. The last bit of sort of advertising is, so we are hiring, right? Like sort of or so. I mean, we are interns, postdocs, scientists, engineers. Also, if you're curious about Qatar as a place to actually spend your life, sort of or so, I'm happy to talk about life in the desert. And that's it.
Thank you very much.